Hi everyone, I am Kiranmai. Welcome to my channel Chemistry Tutorials by Kiranmai. Today in this video I am going to discuss about atomic models. In the last video we discussed about the discovery of subatomic particles. So after the discovery of subatomic particles, that is the particles carrying the charges proton and electron, scientists were facing few major questions at that time. That is how the atom is stable. That is the stability of atom is the first question, as the atom contain positive charge and negative charge, how the atom is stable. So major questions are: first one, stability of atom, and then the other question is how elements are compared, that is how to compare the behavior of elements in terms of physical and chemical properties. Behavior of elements in physical and chemical properties. That is, if you compare the two elements, carbon and nitrogen, how they differ from each other in physical properties and chemical properties. Next question is how to explain the formation of different kinds of molecules by the combination of different atoms. Simply, uh, the question is how molecules are formed by the combination of different atoms. And then origin and nature of electromagnetic radiation absorbed or emitted by atoms. Some studies showed that atoms absorb electromagnetic radiation, it also emits electromagnetic radiation. So, what is the origin of this electromagnetic radiation? How electromagnetic radiation's behavior is there? These are the few questions before scientists to answer. So, to explain all these questions, scientists proposed the structure of atom, which in turn explains these questions. So, scientists proposed different atomic models to explain the distribution of positive and negative particles within an atom. Some of these models were not able to explain stability. I am going to discuss about two models in this class. First one is Thomson's atomic model and second one is Rutherford's atomic model. So first one, Thomson's atomic model. This was the first atomic model, we can say, proposed by the scientist. Thomson is a physicist. He also got a Nobel Prize in 1906 for his theoretical and experimental investigations on the conduction of electricity by gases. According to Thomson, atom possess a spherical shape. Has spherical shape. And in this, positive charge is uniformly distributed. This green color, let's say the positive charge, it is uniformly distributed throughout the atom, and the negative charge are embedded into it. These are the negative charge which are distributed all over the atom in such a way that the they are arranged in most stable manner through electrostatic arrangement. That is, the positive charge and the negative charge in it are balanced. It looks like a watermelon, so this model is also known as watermelon model. So here the positive charge is uniformly distributed as it's in watermelon red color part, and in the watermelon the seeds are compared with the negative charge. That means protons are uniformly distributed throughout the atom, and electrons are embedded into it in a most stable electrostatic arrangement. And the important one is mass of atom is uniformly distributed. See, mass of the atom means the not only positive charge, the mass of the atom is also due to neutrons. So according to this model, the mass of the atom means protons and neutrons are uniformly distributed throughout the atom. So it can explain this model, Thomson atomic model explains overall neutrality of the atom. Means overall neutrality means the atom must be neutral. It should not have any charge, positive charge or negative charge, like ions. It should be electrically neutral. Means how much positive charge is there, it must be equal to the negative charge in that atom. But these model cannot explain the results of later experiments. So this is the drawback of Thomson atomic model. It can explain neutrality of the atom, but it cannot explain the results of later experiments. Means the scientists conducted different experiments, and the results of those experiments were not explained by Thomson's atomic model. Let's see one such experiment that is conducted by Rutherford. Rutherford's atomic model. Rutherford, along with his students Hans Geiger and Ernest Marsden, conducted some alpha particle scattering experiment. Alpha particle scattering experiment. In this alpha particle scattering experiment, they made to incident alpha particle on a thin gold foil and studied the result. The apparatus of this experiment are as I am drawing. There will be a source of alpha particles. Can you guess what is the source of alpha particle? Yes, radioactivity. So radioactive elements in their decaying process releases alpha particle. These alpha particles are made to incident on a thin gold foil. This gold foil is surrounded by a photographic plate coated with a fluorescent or phosphorescent material like zinc sulfide. Coated with zinc sulfide. Alpha particle means alpha particles are positively charged one with two protons and two neutrons. They are made to pass through a lead plate just to make sure it to get a beam of alpha particles. Means if we don't place this lead particle here, the alpha ray particles will be scattered. So to avoid that one and to get a beam of alpha particle, we are using lead plate. And then these alpha particles are made to incident on a thin gold foil. And when these alpha particles get scattered and then incident on zinc sulfide coating on photographic plate. This zinc sulfide is a fluorescent or phosphorescent material. When the alpha particle strikes this zinc sulfide, we can observe a bright spot. These observations led to the discovery of the structure of atom. See, these gold foil, let's zoom this part. Let's assume the gold foil like this. The alpha particles are bombarded or made to incident on these gold foil. These alpha particles move through this gold foil. Few of them move straight, some will be deflected. According to Thomson, uh, earlier as the Thomson model, As the mass is uniformly distributed, Rutherford thought that the alpha particles penetrate through the gold foil but may be deflected a part of it. That means it slows down its velocity or speed through the gold foil, but there will be a little change in direction by a small angle. This is the view of Rutherford while conducting this experiment. Means there will not be any deflection in wider angle. Alpha particles just pass through the gold foil without any deflection or with a small deflection, but the speed of alpha particles will be reduced. This is the expected result of Rutherford. But in contrast to this, unexpected results are observed. Observation. Most of alpha particles are undeflected. And small fraction are slightly deflected. And very few are bounced back. See, most of the alpha particles are undeflected. If nothing is there in its path, they will not be deviated or the race will not be slowed down. So this is what happened. Most of the alpha particles are undeflected. It indicates that there is an empty space which allows alpha particles to pass through the gold foil, and small fraction of alpha particles are deflected. This means Rutherford's observation, due to enormous repulsive force shown by the positive charge of atom, causes this deflection. That is, alpha rays are positively charged, and due to the positive charge present in the atom, some repulsion force is developed, so there is a slight deflection in the path of alpha rays. That is, positive charge has to be concentrated in a very small volume that repelled and deflected the alpha particle. See, if this is the atom, the positive charge must be concentrated in a small volume, which causes the bounce back completely the alpha particle, and it also, due to repulsion, it also deflects the alpha particle. And when alpha particle is passing through the atom, which is far away from the positive part, it is going in a straight line, that is, it is not deflected. Based on this conclusion, Rutherford proposed that there is a positive charge within the atom and it is a very small volume. It occupies a very small volume in when compared to the total volume of atom. Means volume occupied by nucleus. Here nucleus means the positive charge of the atom or the mass of the atom is the volume occupied by the nucleus is negligibly small when compared to total volume occupied by the atom. See, if for example nucleus is like a cricket ball, when it is placed in a ground of the radius 5 kilometers, when it is placed in a big ground of radius 5 kilometers, the size of the cricket ball is very small. So when this cricket ball is placed in that ground, we can see more space in it, empty space in it. Similarly, in the atom, mass of the atom, that is the positive charge and mass of the atom, occupies a very little negligible space when compared to total volume occupied by the atom. These are the conclusions drawn from the alpha particle scattering experiment. Based on these experimental results, Rutherford proposed his atomic model. Rutherford's atomic model. Rutherford's atomic model. According to Rutherford's atomic model, positive charge and positive charge and mass of the atom, positive charge and mass of the atom is densely concentrated in a small region. Densely concentrated in a small region. He named this small region as nucleus. Nucleus is a part of the atom in which the positive charge and mass of the atom is located. This nucleus is surrounded by electrons which are moving in circular path with high velocity. Means with high speeds electrons are moving around the nucleus. This we can resemble with the solar system, sun with the nucleus and electrons with planets. See, nucleus, it is surrounded by electrons revolving round the nucleus in a circular path with high velocity. And then in this model he also stated that electrons and nucleus are held together. These two are held together by electrostatic force of attraction. Electrostatic force of attraction. This is the Rutherford's atomic model. So, contrast to the Thomson's watermelon model, Rutherford proposed a planetary model. nuclear model of atom, in which he said positive charge and mass of the atom are densely concentrated in small region called nucleus, and this nucleus is surrounded by electrons which are moving in circular paths with high velocity. This nucleus and electrons are held together by electrostatic force of attraction. But this atomic model has some drawbacks. Drawbacks of Rutherford's atomic model. According to Maxwell, any accelerated charged particle emits electromagnetic radiation. Means accelerated means change in velocity. So here the electrons are charged particles. They are moving in circular paths. So these particles which are in motion on a circular path would undergo acceleration. Due to this acceleration, they emit electromagnetic radiations. Means electrons will emit electromagnetic radiation. Then it will lose some energy. It is giving out energy in the form of electromagnetic radiation. So electrons will lose its energy and fall into the nucleus. Then atom should be unstable. According to Maxwell, when it emits an electromagnetic radiation, electrons will lose its energy. So it will come closer to the nucleus, and at a certain point it will come into the nucleus. When the two charged ones plus and minus comes together, then the atom will be unstable. But in reality, atoms are most stable particles. So Rutherford cannot explain this. Next, we can have a doubt. Electrons can be a static, right? According to Rutherford, they are moving in circular path. He can also say that if he says electrons are static, then there will be no emission of electromagnetic radiation. So energy of electron is not lost. But when electron is static, that is still, then also the nucleus pulls electron towards it and form a miniature version of Thomson's model. See, when electrons are pulled by nucleus, it will be similar to Thomson's watermelon model, right? The positive charge is overall distributed and then the negative charge are embedded in it. This will be the miniature version of Thomson's model. Then also it is unstable. So this concept is also wrong, means electrons are not static. So first drawback is according to Maxwell, accelerated charged particle emits electromagnetic radiation. So as electrons are negatively charged and are moving in a circular path, these electrons get accelerated, so they emit electromagnetic radiation. If electrons emit electromagnetic radiation, It indicates that electrons are losing some energy. When electron loses its energy, it will move towards the nucleus and eventually it will fall into the nucleus. Then atoms are unstable, but in reality atoms are stable. This is not explained by Rutherford. And another one is Rutherford model says nothing about distribution of electrons. Distribution of electrons around the nucleus and the energies of these electrons. It doesn't give any information about the electronic distribution around the nucleus and also the energies of the electrons. These are the drawbacks of Rutherford's atomic model. So in today's class we discussed about the Thomson's atomic model, Rutherford's atomic model and then their drawbacks. In further classes I will be discussing about the Bohr's atomic model. Before discussing about the Bohr's atomic model, I would like to know you some terms used in chemistry. That is, in further before knowing about the Bohr's atomic model in detail, you are supposed to know about the dual nature of electromagnetic radiation, line spectra, and some few terms about what is meant by atomic number, what is meant by mass number, what are isobars and what are isotopes and all. So in today's class I will be discussing about the four terms: atomic number, mass number, isotopes and isobars. So first one, atomic number. Atomic number is the number of protons in nucleus of an atom or number of electrons in neutral atom. Neutral atom. Atomic number means number of protons in the nucleus of an atom or number of electrons in neutral atom. In any element, number of protons is equal to number of electrons unless it is a charged one. If the positive charge shows the loss of electrons and negative charge will show the gain of electrons. So in neutral atom, number of protons is equal to number of electrons. And mass number. Mass number means it is equal to the number of protons plus number of neutrons in the nucleus of an atom. Number of protons plus number of neutrons. Next, isobars and isotopes. Before knowing about isobars and isotopes, let us know about the composition of atom, which can be expressed as X superscript A subscript Z. So here superscript A represents mass number. Subscript Z represents atomic number. This is the general composition of atom, in which superscript on left hand side indicate mass number and subscript Z indicate atomic number. Isotopes, isobars. Isobars means the two elements or two atoms containing same mass number and different atomic number. Means if we write the composition as X, A, Z, they will have same mass number and different atomic number. For example, C6 14, N7 14. These are isobars. They have same mass number but different atomic numbers. Then isotopes. Isotopes means they will have same atomic number but different mass number. Same atomic number, different mass number. For example, isotopes of hydrogen, protonium, deuterium, tritium. So see, they have same atomic number but different mass number. Here the important point to remember is any element's chemical property are mainly due to the electrons present in them, not due to the protons or neutrons. So if the elements have the, if the elements have same atomic number, means they have the same number of electrons, they are supposed to show the same type of chemical properties. So based on this behavior, isotopes are used in many experiments to know the behavior of the compounds. So these are isotopes, isobars, atomic number and mass number. This is the today's video. If you have any doubts, feel free to ask me in comment box. Thank you for listening. If you like this content, share with your friends